In 1994, the Kitasato Institute celebrated its 80th anniversary. The founder of the institute, Shibasaburo Kitasato, made a great contribution to the establishment of bacteriology and immunology studies, and the institute has faithfully maintained the tradition established by its founder. It was about 300 years ago when the existence of microorganisms was first discovered. Employing a simple hand-made microscope, Antony von Leeuwenhoek observed and recorded the existence of microorganisms. It was impossible for him, however, to know their relationship to human diseases. About 100 years later, Edward Jenner saved the lives of numerous people dying from smallpox by vaccination. He discovered a treatment by immunization without knowing the causative entity of smallpox. It was Louis Pasteur who gave the answer to the difficult question, what are microorganisms and where do they come from? He proved that wine does not decay nor ferment without the presence of microorganisms, demonstrating that fluid cultivation and heat sterilization can control the life of microorganisms. Robert Koch, who lived in the same age as that of Louis Pasteur, demonstrated that all infectious diseases are caused by their specific causative microorganisms. The solid culture medium devised by Koch enabled the isolation of different microorganisms. Employing this technique to its full extent, he discovered the causative microorganism of tuberculosis, cholera, etc., and engaged in the development of their immunological treatment. Thus, the first steps of bacteriology and immunology were started by Pasteur and Koch. Both Pasteur and Koch showed their great appreciation to a Japanese scientist, Shibasaburo Kitasato. Pasteur stated in a letter to Kitasato, "Please accept my heartfelt respect and compliments for your wonderful research activities." Shibasaburo Kitasato was born in 1853, 15 years before the beginning of the Meiji era in Kumamoto. Shibasaburo was admitted to Kumamoto Medical School at the age of 18. Here he is standing by his teacher, Mansvelt, who strongly encouraged Shibasaburo to devote his life to medicine. At the age of 22, Shibasaburo went to Tokyo, the capital, to enter Tokyo Medical School. Following graduation, he became a government official in the Ministry of Health. Shortly after, he was dispatched to Germany to study medicine. He was admitted to the Department of Hygiene at Berlin University. This department included the research laboratory of Robert Koch. Robert Koch admired the unusually hard work of Shibasaburo in the laboratory. He was trying to accomplish pure cultivation of tetanus bacilli, an extremely difficult task in those days. When tetanus bacilli grows on a solid medium, it forms colonies proliferating in a deeper layer of the medium, namely distant from the air. While repeating the cultivation of tetanus bacilli, Shibasaburo discovered that tetanus bacilli are anaerobic. Shibasaburo tried, first, to sterilize contaminated material obtained from a patient by heating, and then attempted trying the cultivation of tetanus bacilli. Kip's gas generator was used to produce hydrogen gas, and this was introduced into a special turtle-shaped Petri dish to remove the air contained inside. When the glass tubes at both sides of the Petri dish were closed, pure tetanus bacilli grew in the Petri dish. A stained preparation of Clostridium tetani. Tetanus bacilli have a characteristic drumstick-like shape. Next, the bacilli are observed under phase contrast microscope. This characteristic shape of the bacilli was employed as the symbol of the Kitasato Institute. Following the success in the pure culture of tetanus bacilli, Shibasaburo started an investigation of tetanus toxin, erythrocytes, which are subjected to destruction by a tetanus toxin. Moreover, Shibasaburo discovered the production of antitoxin, which specifically neutralized tetanus toxin and was produced in the blood of an animal, repeatedly injected with a small dose of tetanus toxin. When antitoxin is added to the test tube containing toxin solution, soon there appear fine masses of toxin-antitoxin aggregation, demonstrating neutralization of the toxin. When serum containing antitoxin is injected into a non-immunized animal, this animal obtains immunity. This is so-called serotherapy. This serotherapy is still important today. For example, there exists no other treatment for snake bites by vipers, habu, etc. Following the great success of serotherapy for tetanus and diphtheria, the name of Shibasaburo Kitasato became known to the world. Participants at the International Medical Congress held in 1891. Among many world-famous medical investigators, you will find Elie Metchnikoff standing side by side with Kitasato. Metchnikoff was the man who discovered the presence of leukocytes, which destroy pathogenic microorganisms, indicating the presence of cellular immunity. Progress in medicine has made it possible to draw a detailed schematic presentation of immunity. Against bacterial or viral infection, a living body protects itself by cooperation of two immune mechanisms. One is cellular immunity. Macrophages and varying T cells directly destroy the intruder. And the other is humoral immunity. This is handled mostly by B cells. Plasma cells derived from B cells produce antibodies to neutralize toxin. They also destroy microorganisms by having the cooperation of complements. The series of reactions mentioned are so-called antigen-antibody reactions. Shibasaburo started his research activities from the investigation of bacteria and their toxin. These studies led him to the great discovery of antibody production in the serum by toxin. Serotherapy based on antigen-antibody reactions was accomplished by Kitasato. He left big footprints on the map of immunology. Kitasato's achievements received great admiration from all over the world. The things displayed in the Memorial Hall eloquently tell us of his greatness. This is an album sent to Kitasato from members of Koch's laboratory with their affection when he returned to Japan after 6.5 years of study abroad. Shibasaburo, who came back from his study abroad in 1892 at the age of 39, opened a private institute for infectious diseases in Shiba, Tokyo, and became its president. The establishment of a research institution, a long-cherished dream for Shibasaburo, was realized by the support of Yukichi Fukuzawa. From that time, Fukuzawa was a great supporter of Kitasato, both physically and spiritually. Soon after, the free spirits of Fukuzawa and Kitasato preferred to leave the Institute for Infectious Diseases and to establish the Kitasato Institute. The Kitasato Institute, based on Robert Koch's institute, was established in 1914. With his deep respect for Koch and with an eagerness exceeding his days in Germany, Shibasaburo devoted himself to the research activities. With the great discovery of the causative organism of plague, the Kitasato Institute had become one of the world's 3 major institutions, together with the Pasteur Institute and the Robert Koch Institute. Under the guidance of his scientific knowledge and devotion to research work, numerous scholars came from the Kitasato Institute. Taichi Kitajima accomplished the serotherapy of the venom of habu. Kiyoshi Shiga, the discoverer of dysentery bacilli, was the pioneer of chemotherapy. Following the discovery of salvarsan, Saihachiro Hata succeeded in the chemotherapy of syphilis. Mikinosuke Miyajima made a great contribution to the development of parasitology. Hideo Noguchi made a great contribution to the studies of syphilis and yellow fever. Numerous investigators are following in their footsteps. The Kitasato Institute made a great contribution to the development of medicine. The first private institution for infectious diseases was established in 1892. In the following year, 1893, a tuberculosis sanatorium, Tsukushigaoka Yojoen, was added to this institution. Later, this addition of a tuberculosis sanatorium was a great help to the establishment of the Kitasato Institute. A few years later, the private institution for infectious diseases was taken over by the government, and the Kitasato Institute was established in 1914. Kitasato, who was strongly against the one-sided attitude of the government, and all the followers working under him, resigned from the Institute for Infectious Diseases, and they all moved to the new building of the Kitasato Institute. While at the same time, the Institute for Infectious Diseases was attached to the University of Tokyo. Meanwhile, Kitasato devoted himself to the establishment of the medical department in Keio University in order to return the favors he had received from Yukichi Fukuzawa, the founder of Keio University. At the same time, a hospital was built and attached to the Kitasato Institute. Tsukushigaoka Yojoen was included in this hospital. The institute became an incorporated association, and it still remains so today. Shibasaburo Kitasato died in 1931 at the age of 78. He is enshrined in the Koch Kitasato Shrine, standing next to the main building of the institute. It was the shrine originally dedicated to Robert Koch by Kitasato, but now Kitasato himself is also enshrined in it. Overcoming various hardships during the Second World War, Kitasato University was established when the institute celebrated its 50th anniversary in 1964. The university is continuing expansion year after year. At present, the stout trunk of the Kitasato Institute has expanded into varying branches of follow-ups in basic medicine, development of new drugs, education, and the practice of medical knowledge. Basic studies have always been the main subject of research work at the Kitasato Institute. Studies on various intractable diseases, including bacterial and viral infectious disease, liver diseases and cancers, etc., are in progress. Unique studies of Oriental medicine are in progress at the Kitasato Institute. The Oriental Medicine Research Center is the first research laboratory of Oriental medicine in Japan. And utilizing the achievements of 2,000 years of Chinese medicine, treatment of patients and basic studies are in progress. Kitasato's pioneering spirit in immune therapy is still working in the field of studies and production of vaccines and sera. Sera and vaccines, indispensable for the diagnosis, prevention and treatment of infectious diseases and the production of drugs for animal diseases, are highly thought of throughout the world. In the field of chemotherapy, a number of antibiotics have been developed at the Kitasato Institute. World-famous therapeutic drugs such as leucomycin, mitomycin, ivermectin, etc., were developed by the research groups of the Kitasato Institute. The efficacy of mitomycin is confirmed under the microscope. Observed like cobblestones are cancer cells. Mitomycin is applied to them. Cancer cells are destroyed one after another. Shown here are small worms called Onchocerca volvulus, a kind of microfilaria, which is the causative organism of onchocerciasis. This worm is transmitted by a blood-sucking gnat, and when a larva enters the body, the eyeballs chiefly are invaded and eyesight is lost. This is a tropical disease prevalent in Middle and South America as well as in Africa. The number of patients is roughly 20 million and approximately 100,000 persons are blind. The first antibiotic effective against parasitic infection like onchocerciasis was ivermectin. The WHO is attempting the control of onchocerciasis employing ivermectin. Filariasis is disappearing by the use of ivermectin. The Kitasato Institute has introduced a new fashion into clinical medicine. The Kitasato Medical Center Hospital was opened in commemoration of the 75th anniversary of the Kitasato Institute and was dedicated to sincere medical treatment. Patients suffering from physical troubles are first welcomed to a gallery of pictures to soothe their feelings. A relief of a microorganism producing ivermectin is also displayed. Advantage of the latest medical achievements is taken in this hospital, with the sincerity of the people working there. Shibasaburo Kitasato was a man who tried to utilize all the medical achievements for practical medicine. All research activities, sooner or later, must protect human life. Shibasaburo Kitasato's belief was that all studies are for the protection of human life, and this belief has been followed continuously by the Kitasato Institute. Steady basic research and practical medicine to protect human life will continue to flourish in the Kitasato Institute.